X gon' give it to you. I'll wait for you to get it on your own. X gon' deliver to you. Knock, knock, open up the door, it's real. With the non.
Okay, hello everyone, and today we'll be going over the Pythagorean theorem and the distance formula. And my name is Nick Battistelli, and I'm sorry my nose sounds very nasally. I am sick today, but it's alright, let's keep going. Now you may be wondering, well, what are these equations used for? Well, the Pythagorean equation is used to find side lengths of a right triangle. Now you can find either one of the legs or the hypotenuse as long as you have two other pieces of information. The distance formula finds the distance between 2 points on a graph. Okay, now let's do an example of the Pythagorean theorem. So, let's say you have a right triangle, right? And you have side lengths of 4 and 6. Well, let's plug it in to the Pythagorean theorem. Okay, so you have 4 squared plus 6 squared equals c squared, because we don't know what c is. Right? So what's 4 squared? 16 plus 6 squared is 36. That equals c squared. 16 plus 36 is 52, and that equals c squared. Well, how are we going to find c squared? Since this has an exponent of 2, you want to square root this, and if you're going to do it on that side, you have to do it on this side. So that tells us the hypotenuse length. So the hypotenuse length is square root 52. That's one example. Now for another example, I'll show you how to use this to find one of the side lengths. Okay, so let's say you have a right triangle, which you will have to have a right triangle, and your hypotenuse is 5, and your side length is 3. So let's plug it in. A squared plus b squared equals c squared. So we know one of those side lengths, so I'll just choose this to be b squared. So you write a squared plus 3 squared equals the hypotenuse length squared, 5 squared. Okay, so write it out again. A squared plus 9 equals 25. Okay, and now you want to have 25 minus 9. So you minus 9 here, minus 9. Says a squared equals 16. Now what do? You have to square root it just like you would do if you were finding the hypotenuse. Square root, well, since the square root of 16 is a whole number, we know that is 4. So now coming back here, this leg length is 4. So here I'll explain how this is easily used in many areas of math. So whenever you have a right triangle, you can use Pythag to help you find A, B, or C. And it helps you find any of these side lengths. So one thing you have to always remember is that your triangle has to be a right triangle. It has to have a 90-degree angle here, or else Pythagorean theorem will not work. Also, it can be any right triangle. You can even find the hypotenuse in a special right triangle. So say it's 4 and 4. Right? We'll just plug it in real quick. 4 squared plus 4 squared equals c squared. And that is 16 plus 16. That's 32 and equals c squared. Well, there you go. This hypotenuse is 32. It's that easy. This helps you find any of these side lengths as long as it's a right triangle. Okay, now let's do an example of the distance formula. So first, you need 2 points. So 5, 2, and 6, 8. Go with that. So let's label them. You have x1, y1, x2, y2. Put a comma there. Alright, so here's the equation, which you're probably going to want to write out first. Okay, and there's that. So now you just basically plug it in. So now it's the square root of x2 minus x1, parentheses squared, plus y2 minus y1, parentheses squared. So now solve it. So what you're going to want to do is you want to find the parentheses first. So it's 6 minus 5, that's 1 squared. And this is a minus 2 is 6 squared. And there's still a radical over here. So now it's 1 squared, obviously that's just 1. And then it's plus, so 1 plus 6 squared, 36. So now here you go. 37, you add it, and that's your answer. So this is telling you root 37 is telling you the distance between these 2 points on a graph. And you can use this for any points anywhere on the graph. Big or small, it doesn't matter. Now I want to show you something that you should watch out for, but you'll be lucky enough not to make a mistake. Say you accidentally switch these, right? These two, you switch them on your equation. It actually doesn't matter, thankfully. So say now x1, it's 5 minus 6, parentheses squared, 2 minus 8, parentheses squared. So here it's negative 1, parentheses squared, plus, let's see, that's plus negative, obviously, so it's negative 6, parentheses squared. Now you can see here we have two different findings. These are negative and these are positive. But with this exponent of 2, it really doesn't matter. So it comes out negative 1 times negative 1 is still just 1, plus negative 6 times negative 6 is still 36. So you're lucky enough that it doesn't affect the change. But what will affect it is this plus symbol. Don't forget, don't accidentally put a minus sign. Okay, so in case you were confused or anything, I'll do another example. It's very simple. We'll go 4, 7, and 3, 9. Alright, so here's your x1, y1, x2, and y2. Now as you start out any math equation, you want to write out the formula. x2 minus x1, parentheses squared, plus y2 minus y1, parentheses squared. Now you just plug it in. So square root of x2 is 3 minus 4, parentheses squared, and y2 minus y1 is 9 minus 7, or plus 9 minus 7, parentheses squared. Now what's 3 minus 4 is negative 1, parentheses squared, plus 9 minus 7, 2, parentheses squared. Keep the radical, put another radical, that is still 1, plus 2 times 2 is 4. So here, the distance between, so that's root 5, the distance between these 2 points here, 4, 7, and 3, 9, is rad 5. That's your answer. So, as you can see, both of these equations, the distance formula and the Pythagorean theorem, both are very helpful in day-to-day math. 8th grade, 9th grade, 10th grade, it all helps. Like I said, distance helps you find the distance between 2 points on a graph, and the Pythagorean theorem lets you find side lengths, which are actually called legs. I don't think I mentioned that. Or the hypotenuse, which is this third longer angle. And remember, you have to have at least 2 pieces of information, either those two, or those two, to find the third. And the distance formula, what you'll need is 2 points, right? And x and y, and that will let you find that. Alright, thank you.
X gon' give it to you. I'll wait for you to get it on your own. X gon' deliver to you. Knock, knock, open up the door, it's real. With the non-stop pop out and stainless steel.